All right, so we're looking at this problem here. All right, the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,000.50 is collected. How many children and how many adults attended? The hint, think linear systems of two variables. Okay, you guys kind of have an idea what that looks like. Second hint, let C be the number of children who attended and let A be the number of adults who attended. Typically, you're not going to have these hints, but I know this is kind of a review from a couple weeks ago or so. So this would really be the first step to this type of problem, is letting a variable represent, or variables represent what you don't know. Okay, so we look at, it wouldn't really do us any good to just write something like this. So I'm showing you what really would help. Okay, we say, okay, well, C is the selling price of a child's ticket. Okay, well, you found C, right? Like, who cares, kind of thing, right? So that is why we are letting C be what we don't know. We don't know the number of children who attend. That's what we're going to find. And we don't know the number of adults who attend. We let A be that. So we let your variables represent what you don't know. I can't emphasize enough that how important that is to solve any word problem. Okay. So for here, okay. So let C be the number of children, and let A be the number of adults. I don't know why I did it just for that little bit. All right, so some of you got it. Good job for those that did understand what's going on here. So I'm going to now try to make some statements that I know are true. If C is the number of children and A is the number of adults. One's really easy. On a certain day, 2,200 people enter the fair. Well, C is the number of children, A is the number of adults, so it should be true that C plus A is 2,200. So number of people. And the other piece that I got to figure out is, okay, I know that $1.50 for children per child ticket and $4 for an adult ticket. Okay, so it should be true that the total revenue would be $1.50 per the number of children's tickets plus $4 per the number of adult tickets, times the number of adult tickets, should equal total revenue of $5,050. What's that? 2,200?
Yeah.
Not well, it's a fair. Okay. Yeah, I didn't mean to come off with weird name. Yeah, that's not uncommon. I think a fair, 2,000 people. Like, how many people are in the school? Does anyone know?
Around.
Ooh, there you go. That's the question of the day. How many students go to my school? All right. So, how many students go to my school? So, there's two methods to solve this. There is substitution and there is elimination. It doesn't matter which one you use. I think elimination is probably the better route to take, especially when you deal with three variables. I think substitution takes more time a lot of times. So I'm just going to stick with elimination, but there's nothing wrong with setting this as C equals or A equals whatever and then substituting. But let's do elimination. So, and it doesn't matter which variable I want to eliminate, whether it be the C's or the A's. I'm going to eliminate the A's. All right. So I'm going to multiply this guy here by -4, good, giving me -4C plus -4A is equal to -8,800. And if I bring this guy over, I'm going to have 1.5C plus 4A is equal to 5,050. And then now from here, so again, the reason I'm multiplying by -4 was that would make the exact opposite coefficient as this guy of this A, right? I have -4A, and this guy's 4A, so now they're going to go away nicely when I add all these. For those of you that are comfortable doing subtraction, you can find that's okay. I'm going to try to stick to addition just to avoid silly mistakes. So if I go ahead and I add this, what's -4C plus 1.5C?
Positive 3.
No. -4C plus 1.5C?
-3.
No.
1.5.
No.
Yeah. No.
I've heard 2.5. I've heard -3.5.
-2.
There you go. Good. -2.5C.
Oh, okay.
Sorry, what's that? Yep. Yep. Plus -4. Yep. Just distributing the -4 to each term. Now I'm adding. Now these cancel. -4A plus 4A is nothing. And this equals -8,800 plus 5,050. Which one is that? -3,000. -3,750. Thank you. All right. The reason we eliminate is now we have a single variable equation that's linear, so it's nice and easy to solve for C. I'm going to go ahead and shrink this down. That's kind of weird.
What is 1,500?
It's kind of weird it does that.
Oh yeah, make a box around the.
Yeah, I guess I could try that. Let's see.
Because the size of the building.
Too small. All right, so here we go. Divide both sides by -2.5. And C equals 1,500.
Hey, can't you plug that in for the first one? The first equation? There's no good.
Yep. So now we can do a combination of substitution. You know, we don't have to strictly do elimination, right? We don't have to like, okay, I eliminated my A. Now I'm going to go back to here and I'm going to eliminate my C's. You could do that. You could do that if you want, but you don't have to. I'm actually just going to substitute. So I'm going to plug this back in. So let's say this guy here, the first one, C plus A equals 1,500.
Wait, no, it's 22.
And, oh, sorry. So 1,500 plus A equals 2,200. And then subtract 1,500 on each side. So A would equal 700. All right, so we, according to this, 700 adults and 1,500 children. If I got a fractional value for either A or C, would that make sense? Why not?
Because you have a lot of
You can't have half.
Right, cannot have, yeah, fraction of a person.
I mean, if they miss it, somebody hurt.
I mean,
If I have, we still count that person as one.
yeah.
Yeah.
like,
That person count.
what about those conjoined? How does that work? Do they have about two digits?
Two different brains and consider two different people.
No, they're not signing this one. That's conjoined.
I know what you're talking about.
It's still two.
It's the same thing.
It's basically, well, what do you want to do today? Well, I want to do this. Well, today's your day. And tomorrow's my day. We do what I want to do. I guess it's probably how it works.
No, I'm saying not like that, because most conjoined is when they're friends, I mean, they have no choice, but I'm just saying, like, how does that work in reference to design? Like, if they want, like, admission, they have to take people.
It's a good question. It's a good question. It's probably up to the owner.
Yeah, I bet you.
Yeah.
I don't think
It's a funny question. So, if either of these were negative, that should also be a red flag. Right? Can't have a negative number of people, can't have a fractional number of people. So, these look good, right? But how do I know these are the exact, how do I know these are right?
You have to plug it in.
You have to plug it in, exactly. I have to plug it into not only one, but I need to plug it into the entire system, right? Because I have a system here. So let's see, the first one, 1,500 plus 700 is 2,200. Now with the calculator, if I plug in 1,500 into C, what's 1.5 of 1,500? Is that 2,250? Plus 2,800 would be 5,050. So it works. Okay, check here and check here.
I wish you would have did this before first period.
Before first period.
About success first period.
Ow.
Any questions? So where we left off with this yesterday, we ended up graphing this.
No, we didn't do that. We did something else.
F of x equals 0.4 times x minus 1 squared.
Nope.
No?
Nope.
Okay.
We did that and that.
Okay. So let's review this. You guys are a little bit ahead of first period, which is good for you. Right. All right. So we have. Let's review these. For the three different forms of a quadratic, we have standard form, vertex form, and the newest one is intercept form. But it's very easy. When it's given to you like this, obviously P and Q are both are the x-intercepts. It would make the value of the function equal to 0. And then all this is saying is that for the axis of symmetry, we lie halfway between the zeros. We know all of these parabolas are symmetrical about the x-axis. Right? So if I know the values of the zeros, then it should be halfway between them. Because we don't have any parabolas that are tilted like this. We're not dealing with those, right? We're just dealing with standard parabolas that are straight up and down, or up and up, or both down. That's it, right? There's no tilting here. So this will work out fine. So be sure to understand these. If you don't know them, definitely this is a good note to have in your notes. Standard form, x equals negative b over 2a would be the axis of symmetry. Now, here the vertex would be whatever the x-coordinate is, whatever this is, and then the value of the function f of negative b over 2a would be the y-coordinate of the vertex. Right? If I know the x-coordinate of something, I can just plug it in and get the y-coordinate. Yes?
So for the standard form, would you take b times whatever x is and then plug it in to be negative b over 2a, or just b? Like whatever version you want is. Like let's say b is 2.
Okay.
And x is like 3.
X is 3. No, x is x.
X is x, but like once we find
Are you saying if you found out that x equals 3 for the axis of symmetry?
yeah.
Okay, so let's say you find out that x equals 3. Because you know what b, you're going to know what b and a are, because they're going to be actually filled in values.
Yeah.
Okay?
So we would just take whatever b is and plug it in.
No. So you're going to take that, if you find out that x equals 3,
Yes.
that is the x-coordinate of your vertex, because the axis of symmetry runs through the vertex.
Okay.
Right? If I have I have this going on, here's the vertex, the axis of symmetry is going to run right through it. So it makes sense that this point here is going to have the x coordinate of whatever the equation of this, whatever x is for this equation.
Alright, so whatever negative b over 2a is,
Yep.
that's the axis of symmetry.
Yep.
Okay.
So let's say the axis of symmetry is x equals 3. Then you already know the x coordinate of the vertex. To find the y coordinate, you simply plug in 3 into the function.
Oh, okay. Alright.
Right? Because this gives you the point anywhere for the graph of the function.
Alright.
Yeah, definitely, let's be clear about this, what this means here. Vertex form, given to you in vertex form, h and k of the vertex, x equals h would be the axis of symmetry. And this would be the axis of symmetry for this guy. So you will be expected to know this for your test, which I'm shooting for next week. No, next week is better.
We have a test.
What's that? No. Oh, I'm gonna let you guys know that. So looking at this function here, f of x equals 0.4 times x minus 1 squared. Okay. So for the test, you need to be able to describe all the transformations. That includes horizontal translations, vertical translations, vertical stretching or vertical compression, and reflection about the x-axis or not. Okay. What's that?
That's the A, right?
Yeah, so the value of A tells you the vertical compression or stretching. It tells you the reflection in the x-axis or not. Yeah, that's what the A tells you. So let's take a look at our A for this guy, which now, do we all agree that this is in vertex form? I heard no. Oh, yeah. Okay. So this is in vertex form. Now, I didn't have to put plus 0 on the outside. In fact, it wasn't written like that. I'm just doing that to be clear that k is definitely 0, right? So if you were given this like this, you would know intuitively that k is 0, right? Because it's not written out here. Okay. So the vertex here would be 1, 0, h, k. What are you looking at, Anthony? Let's not pick at the wall. Alright. So here is the vertex form. F of x equals a, parentheses x minus h, close parentheses squared plus k. So you guys are, I'm telling you now, so you need to have this memorized, vertex form. Okay. So just to review, we graphed the vertex at 1, 0. And then now what I'm saying is once we have the vertex graph, we can just pick some points left and right. Right? I'll pick a value just to the right of the vertex, say when x is 2. Plug it into the function to see what the output would be. I saw some students were getting this wrong. So if I plug into, let's be careful, 2 minus 1 is 1, 1 squared is 1, 1 times 0.4 is 0.4. Now I should, go ahead.
Did you just say 2 minus 1 is 1?
Yep.
1 times 1 is 1.
Yep.
Times.
And 1 times 0.4 is 0.4. Yep. So I have that. Now I should expect if I plug in 0 to also get 0.4. Because I know that this parabola is symmetrical. Right? What is the axis of symmetry for this guy? X equals 1. Very good. I'm not going to erase it, man. plug in 3, let's see what I get. I already, obviously it's written here, but let's see if I plug in 3. So you got 3 minus 1 is 2, 2 squared is 4, 4 times 0.4 is 1.6. All right, so I get an output of 1.6 when I put 3. And that was just 2 horizontal units to the right of the vertex. So if I input a value x that is just exactly 2 to the left, I should expect the same output. So when I plug in -1, -1 minus 1 is -2. -2 squared is positive 4. 4 times 0.4 is, again, 1.6. So you should feel pretty comfortable when you're doing these, and each point is making sense that you come up with. I didn't have to do 7. I decided to do 7 just to make it look more accurate. Plugging in 4. 4 minus 1 is 3. 3 squared is 9. 9 times 0.4 is 3.6. Plugging in -2, you would also get 3.6. And graph it. Okay. Now while we're here, let's just go ahead and list what's our A. Good, 0.4. Okay. So because this value is A is greater than 0, what information does that tell us? So let's say on the test, you don't give me graphically, but you're just told that A is greater than 0. What do you automatically know about this guy? That's not necessarily
It's not
true.
flipped over yet, so.
That's what I want to hear. Because A is positive, compared to the parent function, there's no reflection in the x-axis, right? So this here, we'd say there's no reflection in the x-axis. Of course, I'm always talking about compared to the parent function. Let's go ahead and graph the parent function. 0, 0. What I have, the parent function, let's say, is g of x is equal to x squared. This would be the parent function. So when we plug in 1 for x, we get 1. We plug in -1, we get 1. We plug in 2, we get 4. We plug in -2, we get 4. We plug in 3, we get 9. And we plug in -3, we get 9. And then graph this guy. So you can visually see that the blue function has been shifted, and it has been what? How would you describe it? Vertical compression or vertically stretched?
Wait.
Compression. And the reason is, we say it's vertical compression, is because the absolute value of A, I'll do purple. The absolute value of A is between 0 and 1. So therefore, it's vertical compression.
Wait, can you say from blue to white or to vertical?
From compared to the parent function, it's been vertically compressed.
Oh, okay.
Vertically compressed by a factor of, I'm fine if you guys put 0.4 or 1 over 0.4. I understand that you guys know what compression means, so I'm not concerned whether it's written as 0.4 or 1 over 0.4. It's compression. So here's the two distinctions you got to make using the A value. The fact that the A is positive alone tells me there's no reflection in the x-axis compared to the parent function. The fact that the absolute value of A is between 0 and 1 tells me that it's vertically compressed by a factor of 0.4. Any questions about this? Otherwise, if there's no questions on this, I think we'll plan on looking at reviewing some systems with 3 variables. So that you're good for the test? Okay.